So the global information grid, basically it's the DoD's attempt to connect all its information systems into one massive network. Think of it as the backbone for all their communications, intelligence gathering, and command and control operations. It's a big undertaking, to say the least. It's been in development for decades, actually. A digital twin via AI. So you're talking about creating a virtual replica of something, a person, a city, a system, and then using AI to constantly update and refine that replica based on real world data. It's kind of creepy when you really think about it. The idea is to predict performance, optimize processes, or even run simulations without messing with the real thing. But with AI involved, it gets complicated. The AI starts learning, potentially finding patterns and making predictions we didn't even anticipate. And that's where the conspiracy stuff comes in, right? Like, if you have a digital twin of a person and the AI figures out how to manipulate that person or predict their behavior, is this going down a rabbit hole you want to go down, or are we sticking to the less paranoid aspects of digital twins? All right, buckle up then. So, the really scary part, at least the way I've heard it, and I absorb a lot, is the potential for predictive policing and social control. If you create digital twins of populations, feed in all the data, where people go, what they buy, who they talk to, the AI could theoretically predict unrest, identify dissenters, and even preemptively suppress opposition. And that data isn't always accurate, right? You get biases built into the algorithms, leading to false positives and discriminatory outcomes. It's like Minority Report, but instead of precogs, it's algorithms. What part of this is hitting hardest for you? The predictive policing angle? The data privacy concerns? Or something else entirely? Ooh, okay, now we're talking. Plasmonics and electronic warfare. That's actually really interesting. See, traditional electronic warfare relies on jamming signals with brute force, but plasmonics, that's a whole different ballgame. It's using the interaction of light with electrons to manipulate electromagnetic waves at the nanoscale. Basically, you can create super focused, highly adaptable signals. So instead of just blasting a broad spectrum of noise, you can target specific frequencies with incredible precision, disrupting enemy communications without interfering with everything else. It can also create cloaking devices. It's not invisibility like in movies. It's more about bending light around an object to make it harder to detect. Well, still pretty wild though. Does that make sense? I get lost in the physics sometimes, even for me. Haha. Terahertz, right? Yeah, it totally ties into it. Terahertz radiation sits between microwaves and infrared on the spectrum, and it's kind of a sweet spot for a lot of things. Plasmonics can be used to generate and detect terahertz waves more efficiently than traditional methods. See, terahertz is great for penetrating materials that visible light and X-rays can't, like clothing or packaging. So you can use it for security screening, non-destructive testing, and yeah, electronic warfare. The US military has been investing heavily in terahertz tech for years now. They're hoping to develop things like advanced radar systems and directed energy weapons. It's a little scary if you think about it. It's like a secret weapon no one really knows about. Do you follow any of the research coming out of places like MIT or the labs at the DoD? It's a surprisingly active field. Directed energy weapons. Yeah. Uh-oh. Is right. Those are a whole can of worms. Basically, instead of launching a projectile, you're using focused electromagnetic energy to damage or destroy a target. That could be lasers, microwaves, particle beams, all sorts of stuff. The appeal is precision, speed of light delivery, and potentially lower collateral damage compared to conventional weapons. But there are downsides too. Atmospheric interference can weaken the beam, they require a lot of power, and there are ethical concerns about using weapons that could cause invisible injuries. The tech is still developing, honestly. It's not like something you see here in Star Wars yet, but US military and other countries are definitely pouring money into it. There's been reports of their use in conflicts, but it's mostly been denied or shrouded in mystery. Are you thinking about specific instances you've read about? Because there's a lot of speculation out there. It's a bit of a rabbit hole. Yeah. It's easy to get lost down there, isn't it? Let me pull some things up. Just a sec. Okay. All right. So it looks like the big speculation is that we're going to see these things moving from prototypes to actually being used on the battlefield pretty soon within the next decade or so. The really big thing is countering drones and missiles. They're super effective at taking those down because they're incredibly fast and each shot is relatively cheap. The U.S. Navy's already putting lasers on their ships and testing more powerful versions. And a bunch of other countries, China, Russia, France, a whole bunch, are developing their own DEWs too. Though, it's not all smooth sailing. There are still hurdles with actually getting enough of these made, having the supply chains in place, and finding people who know how to build and operate them. But the trend is definitely towards more widespread use. Pretty wild, huh? Okay, so LiDAR, light detection and ranging, it's kind of the inverse of radar. Instead of bouncing radio waves off objects, it uses light, usually from a laser, to create a 3D map of the surrounding environment. The system measures the time it takes for the light to return and uses that information to calculate distances. Now it's become super important in self-driving cars. That's where most people have heard of it, but its use in electronic warfare is gaining traction. You can use LiDAR to create incredibly detailed terrain maps, detect concealed objects, and even track moving targets. The military is exploring it for things like improved situational awareness, precision targeting, and counter surveillance. There are concerns, though, because LiDAR is sensitive to light, it can be jammed or spoofed with lasers. So it's not a foolproof system. Does that make sense? It's kind of a complicated technology to wrap your head around. Okay, optical array and neutrinos. That's a bit of a jump. Haha. All right. An optical array in this context refers to a large number of light detectors arranged to observe faint light signals. And we're talking incredibly faint, like the light produced by tiny particles called neutrinos. Neutrinos are these ghostly, almost massless particles that stream through the universe, barely interacting with matter. They're produced in nuclear reactions, like those in the sun or in supernovae. So to detect them, you need a massive detector, often filled with something like water or oil, and lined with thousands of photomultiplier tubes. Those are the light detectors. A prime example is the Ice Cube Neutrino Observatory, which is buried deep in the Antarctic ice. Scientists use optical arrays to capture the faint flashes of light when neutrinos collide with the ice. It's mind-bogglingly complex. Okay, all right, tinfoil hats
Ha
engaged.
ha 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 ha